Alright, welcome to my Physics Lab 1, which is on charged tapes. My name is Reese Johnson. Alright, to introduce this, the purpose of the lab is to utilize tape in order to gain an understanding of charge transfer between surfaces as well as to estimate the charge and number of electrons transferred. The fundamentals of physics which we will be implementing are Newton's third law and second law of motion, where every force requires an equal and opposite force to counteract it, and force is equal to mass times acceleration. We'll also be using Coulomb's law, where the electric force is proportional to the product of the charged particles divided by the distance between them squared. Electrons can be removed from a surface during interactions between it and other surfaces, and using appropriate approximate radii of atoms to calculate the number of excess electrons per atom within the tape. Alright, so the results of this lab overall were that the charged pieces of tape repelled each other after the charging process. The pieces of tape were positively charged. The charge on one of the pieces of tape is around 1.256 e to the negative 8th coulombs. There are 7.849 e to the 10th electrons which are deficient on the piece of tape. And there are 3.09 e to the negative 7th electrons deficient for every atom on the piece of tape. Alright, so the model which I used was that each charged piece of tape was modeled as a point charge in order to calculate the force charge counteracting gravity. The assumptions used were that each charged tape has the same charge, treating the tape as if all the charge was centered at the very middle of the tape in a single point, i.e. the point charge. These assumptions help to reach a reasonable approximation without including an overly complex calculation. This is my free body diagram on the right side of the screen, where electric force is pushing up on the point charge and then gravitational force is pulling down. And because of Newton's third law, they cancel each other out, and the tape is stationary. Alright, and then on to the experiment. The system was tape A and B because we only pay attention to the interactions between these two tapes with each other and gravity. The surroundings are the rest of the universe, including the room, the earth, and all other things. The initial conditions of the experiment were a single piece of tape, which was about 20 centimeters, was stuck to the desk face down. Two other approximately neutral pieces of tape, around 20 centimeters, were cut and ready to gain charge. The details of experiment included charged tape was created by applying tape A to the desk tape and ripping it off. The charge was ensured by bringing my hand near the tape and checking for attraction. This was repeated for tape B. The next tape was placed near many different charged objects in order to determine the charge of the tape. This included a negatively charged plastic pen, which it was attracted to. Next, tape B was hung across two books, and tape A was brought underneath it until B had a floating effect and the distance between the two tapes was measured. Tape A was attracted to my hand when near it. These were the observations. And tape A was repelled by another piece of tape, tape B. And then tape A was also attracted to a Keurig machine. Tape A was attracted to the negatively charged pen as well. Conclusion, the tape is positively charged, meaning electrons have been ripped from it during the charging process. Tape mass was calculated by the given data, and those are kind of like all the other data points, and those were the manual calculations for the charge, which was 1.256 e to the negative 8th coulombs. The atoms on the surface were 2.54 e to the 17th, and the electrons deficient on the piece of tape were 1.58 e to the 36 electrons. And then this is my coding, in which I used techniques, just basically the same calculations as the manual calculations, and I displayed the print with the print command, and then I made the model with some modeling techniques. The coding and the calculations get the identical results because the same method of modeling is used for each method. And then sources of error may be the charges in each part of the tape may be different from each other. Tape A and B might have different charges, and some charge may have been dissipated due to handling. So the assumptions were basically that I treated the long piece of tape as a point charge, and I assumed each tape had the same amount of charge. And I already talked about the charge that was calculated. Alright, so what if electrons had a positive charge and protons had a negative charge? This would not change any of the observations which I made because the attractive and repulsion force between the two objects are pretty much the same either way, so you would not be able to tell a difference. And then it is also important to handle the charge tapes as little as possible so charge does not dissipate into your hands and the tape does not return to neutrality. Anyways, thanks for listening and have a good day.